Cool. Okay, so that looks like it's working. Today I'm looking at the Ethereum Codebase again. Surprise. I want to look at the account manager package that they've got. So when you run Geth, there is a few options relating to account, which is managing your account. Geth Account. So lists all accounts, importing private keys, creating new accounts and stuff. List, new, update, import are the commands. I don't have any keys on this computer, so when I do list, it does nothing. And this is running on quite a small virtual machine, so when I try create one with it, it spits the dummy and crashes on me. But if we look into the source code, go source GitHub Ethereum, Go-Ethereum, there is this accounts package. And it doesn't actually look too big. CD ABI, what is that saying? But what happens? Let's just actually look at the command. So I'm quite enjoying looking at everything that happens from when you call the program. So if we go into command Geth and we look at account command, this guy here. If we can get it. There is, up the top here, bunch of, so wallet command is account, and I've got an echo, go away. So in wallet, you can import, and that looks like pre-sale wallets. So that wasn't accounts, but this must manage that area too. So you call the wallet command to Geth wallet, and then they got these sub commands. So you can go Geth wallet import with the key file, and it calls this import wallet function. Then we've got account, does something similar. You can go Geth account, and down on these sub commands, there's list, new, update, and import. So I think list will probably be the easiest one so far. But yeah, you go Geth account list with no parameters, and it will give this account list function a call. So we go down, and here it is. And it's small, which is quite good. So the first thing it does is make config node, which I'm pretty sure if we go into here / make config, no, not there. Command Geth. It's in config. That's where it was, wasn't it? No, I went to chain command. That's what I did wrong. Completely wrong one. So we go make config node. we've been through this before, but I didn't specifically see where it actually created the account manager, which is what's being called. Because it looks like they're making this stack, which is just a node. Node or config? Make conflict node returns a node and a Geth config. Yeah, so it makes a node. This stack is the node. And then as part of it, there's this account manager.wallets, which is a function, I guess it returns all your accounts. Yeah, cool. So you got several wallets, and each wallet has several accounts, I guess. So in here we go set node config, eth stats, set eth config, apply flags. So I guess it's in this node.new, which we've looked at somewhere. Into node, and that was in node slash new creates new peer-to-peer node. And what to do? It's node.new and passes the config returning a stack. And in that is an account manager. Which is this. So we're passing the config to here. It does some bullshit with checking the data directory, because if the data directory doesn't exist, it will create a memory database instead of actually using the database. It checks the names, just sanity checks really to make sure shit isn't going to explode when they run it. And here they call make account manager, which I don't know exactly what it does, but it seems like it would make the account manager, which is what is being accessed here. And this doesn't have any namespaces here, so I guess it's in the same place. So make a saving on the spot there and call make account manager. Let's see where it goes. And it's not in there. So that says that somewhere in the node there is an account manager. Maker. And it's in config. So in this config.go file, make account manager. So this config file has a function that just returns this script n, script p, and keydir. I don't know what script n and script p do. N. Bitcoin is the safest. Who knows what they actually do? I'm assuming it's something to do with the public key. It doesn't even look like I can immediately Google it. Cool. So accounts.manager. So in this config, I think there's a config structure in this. Key store standard script N. Password based key derivation function. Looks into the key store. Where does it get that key store from? Key store. Config. There's a key store directory, which if we go into .geth, mine's completely empty. So they got this key store directory, which is where they save all the keys. And I guess there's an init or something that turns that into the actual key store. /make account. So I don't know what the script exactly does right now, but we'll go back to it. Key store, key dir. Yeah, I just don't know where they get that key store from. So if they go into Ethereum node, ACK key store. In doc. var key store error. If key store error, return key store error. Hmm. 425, we reckon. if key directory equals blank, ephemeral equals key directory. See, there's all these. No, there's one there. Defined variables like global variables, and I don't know where they're saved in. Add peer. No, it's not there. So somewhere there's this key store. I'll find it eventually, I guess. If the directory equals nil, they either make the key directory they make a temporary one. If it equals blank, key dir equals temp dir. Go-Ethereum key store. If there's no errors, OS make directory key dir. I think that'll make it even if it's got error equals nil. Assemble the backend manager. Backends equals array account backends key store new key store. So up here it's not actually a variable, it's a library. So in account says key store. Cool, what's in that then? Now we've got the first one. First link to the actual. In key store. Oh, gross. It's a decent size too. So in here, back to our place. There's new key store. But account config, what does that do? Standard script N. Yes. What do we go into accounts? Key store. Standard script. SCRYPTN. Script encryption algorithm. Designed to make large scale standard N, standard P. So the CPU memory cost parameter and a parallelization parameter. Cool. So back down here. That's in key store. So at 4:30, we got this. No, it's in the other one. Key store passphrase. Passphrase. At 52. How big is this? Yeah, it's decent size. Define standard script N is the CPU usage. 1 to the 18. One dot 1.8 equals. 234 262 bytes. Standard script P is 1 second CPU time on a monoprocessor. So that's to take 1 second CPU time, and that's to take 256 megabytes. I guess. Reading this 2.5 seconds of parallelization. Which could be completely wrong, but I don't think it's necessary to understand it completely right now. So if we go back into config, they get standard, which are blank nothingnesses. It's called up here. They pulled a directory out of the config. So if you set it in your flags or in your file, geth config, dump config. Somewhere in here might be a accounts node Ethereum dashboard. ETH hash. There's a data directory that's not in the Ethereum, it's in ETH hash. Interesting. Account config c.keystore directory. So that if it is blank, key directory equals key store directory. So if it's nil, data directory default key store is key store. Cool, so it sets it to the default being key store here. Good. So we get this back. It's got standard, that's like 40,000 in hex. This is a 1, this is account config. If it's still nil, it's because there was a reason for it, and that was the client wanting to use the memory store instead of using it in a database. So if it's that, they use a temporary one, so they don't save it. Make the directory. If it doesn't exist, I think this won't return an error if it has to make something that already exists. Make it dir all. JKLMN process file temp dir make dir all, creates a directory name path along with necessary parents. Ooh, and returns nil. If the path is already a directory, it does nothing and returns nil. Cool. So if it already exists, it just does nothing. Very good. Then we go backends, accounts backend. So, up the top, is there an accounts file? There is. So, in accounts, and there is a backend structure, and I make an array of backends. No, there was a backend file, wasn't there? Was it? Maybe not. Here it is a wallet provider that may contain a batch of accounts so they can sign transactions with and upon request. Of accounts, they can sign transactions with and upon request do so. That doesn't make sense. Wallets retrieve information. Wallets retrieves the list of wallets the backend is currently aware of. So we've got an array of these. Scrolling up just to see what this structure is playing with here. So there's a wallet. Represents a software or a hardware wallet. Has a URL. Is that an interface? Yeah, it's just an interface. So you got a wallet, and the wallet is just something you can call open and close on, and has a list of sign-in accounts. And a wallet can have an account. Sign hash. So say you've got two hardware wallets plugged in. This would be able to say that in this backend interface, you have those two wallets, which are structures in here. And in each of those hardware wallets, you can save the infinite amount of accounts that you want in there. But what's interesting is there's a array of these backends. So they make a backend, and in the backend, there's a key store, new key store, and it takes standard shit to go to it. / backend. Wallet event. So wallet is just an interface too. So something's implementing that somewhere. Cool. There's a lot of reading in that one. I'm not going to read that. But in here somewhere, there is this new key store function. Returns a key store. I guess a key store is a wallet. Does it? Let's go to implement URL status. Self-derived and sign hash and stuff. This is the command itself. Okay, I think we don't need that anymore. So it's all done in this new, and then create a node. Node creates an account manager. Cool. And then they call account manager on it. So a key store is a backend, maybe? New plaintext key store creates it for the given directory. Key store has init. Wallets. Subscribe. Key store has a list of wallets, do you reckon? Yeah, it looks like it. They've got an array of wallets. Account.wallets. Wallets implements accounts backend, returning all single key wallets from the key store directory. Cool. So the backend, a key store is a backend, which has an array of wallets. And they call create new key store to create the first one. So they get the key directory. And they call key store passphrase. KS equals a key store init with the key directory. Key store passphrase. Not in this one, because it's in this one. So the key store passphrase is a structure. I guess it's an account. No. Don't think I need that one anymore. They call new key store. Key store equals ampersand key store. Storage equals key store passphrase. So the key store has a storage, which is a key store. They're the fucking same name, just different. Okay, so the key store dot storage is a key store, which is a different type of key store, I guess. Is it in here? Are they going to tell me what the little key store is? I doubt it. Oh, it's in this one. Little key store, where are you? Key store with a little K. Key store passphrase. Do you reckon it's an interface? I've already looked at this and I've forgotten already. Key. Package key store. Oh, that's scary, because that's got the little key, doesn't it? Here it is. It's an interface. Something that has a get key, store key. So the key store, capital K structure that is exported has a storage. Where are you? Which is one key. And it's just an interface that has get key, store key, or join path. And this passphrase key store is one of those, because it has get key, I guess. Get key, store key. So they create a new one with the path to it. Skip file verification disables the security feature which does read and decrypt any newly created key files. And they pass false here, so they don't skip shit. But these are just generics. So they got a directory that's got generic scripts in it. So they make this, they pass it to here, which goes in as the storage, and that's it. So they just make a key store that has the storage of this key store passphrase, and they call init on it. What's init do? Locks it, have the unlocked keys, unlocked as a structure which has a key, array to a key. Oh, that was in that one. Unlocked account, decrypted private keys. So they're the accounts you can use when you want to call commands and you don't want to have to enter passwords and stuff every time and don't want to load shit. So there's a key, has a UUID, an address, and a private key. A private key in this structure is always plain text. So this is when you actually want to do shit with it. It's unlocked, it's saved into this key. So there's a map of unlocked. So it's got an address and unlocked. And it's unlocked as a key with a channel to remove it, I guess. So they call init. What does init do? They make an empty map of unlocked. They go new account cache. In order for this finalizer to work, there must be no reference to key store. Address cache doesn't keep a reference, but unlocked keys do. Creates an initial list of wallets from the cache. So they're making this account cache, which I guess is just a list of accounts that aren't saved. New account cache, and it's not in this file. Frustrating. Account cache. So in here, there's a new account cache. There's a live index of all the accounts in the key store. So does this key store have a cache? It does. In-memory account cache of the file system storage. So make this cache. It's got the directory, it's got some stuff for concatenation. concurrency. It's got a thing for concurrency, mutexes and shit. Watches, I guess. I don't know what a watcher is. I assume it looks over the directory and watches for changes. Account. A map of addresses to accounts. Timer and a file cache. Creates a new cache. Makes a new watcher. What's the watcher do? / new watcher. It's not in here. Quit. Go source, GitHub, Ethereum, Go-Ethereum, and in here you go into accounts, new watcher, key store watch. What does a watcher do? Has an account cache, started running, event, new watches. Starts a process in the background. w.startIn equals true, startIn is boolean, go w loop. So make this loop. Log new path account, notify.watch, failed to watch, which is an error. So notify.watch, and they got the key directory. What's notify? Yeah, it's a library. RJEC. Zalik. With a K or a C? Watcher. Good work, DuckDuckGo. Found it. Notify. Is that where it was? Notify. Here. What do you do? File system event notification on steroids. Unactive development. Notify. High level abstraction that watches events. So it literally just watches the file system. That's nice. So when there are changes, cool. Kind of guessed that, didn't really need to dive into it, but interesting nonetheless. So the cache creates a watcher and keeps the cache matching what's in the key store directory. Returns a cache, it's got the directory, it's got the watcher in it. And the channel, notify. It returns the channel as well. So if KS changes, is a channel that gets notified when stuff happens. Cool. Set finalizer. Accounts equals cache dot accounts. Where were the accounts made? Key directory by address. No, it's a function. Maybe reload. Calls maybe reload, locks it, unlocks it. Makes a copy of accounts.accounts for lect of ac.all. So what's all? Accounts by URL. Oh, it's an array of accounts. Good work. Figured that one out. So there's accounts by URL, which is just an array of accounts. And when they call accounts, that returns it. So I'm guessing in maybe reload or one of these, they populate the accounts. Scan accounts. If any needs to change, it updates the accounts. Go through all the changes. Cardinality. Scanning contents. Read account equals a function that returns an account's account. So they open the key store file, blah blah blah, put it in a decoder, and a decoder returns it as an account with the address, the URL, and the key store. So in this cache, once it's initted, init wasn't in here. New cache. Yeah, new account cache is created. Then they call accounts. That calls this maybe reload. That goes and checks for what's been happening. This watcher, I guess, returns a heap of events when stuff gets added and subtracted. Maybe reload goes in and checks all those and would be checking all the files and just making sure that any of the new files that are in the key store are to be added to this accounts.all, which is just an array of accounts. And then it makes a copy of them and returns a copy. So now we've got a copy of all of the accounts. ks.wallets. Make an array of accounts.wallets that is the length of the accounts. For each one of them, key store wallet equals the account and the key store. So it makes a reference to itself in there. Makes a key store wallet. So what is accounts then? That's come up a couple times, but I haven't found it yet. Up directory accounts.accounts. Account represents an Ethereum account. It has an address and URL. Optional resource located within a backend. So the account literally just has an address and where to find it. Which is I guess there's a key linked to it, like that other one. Did I see that already? Wallets. A key store wallet has an account and a key store. So in key store wallet, it's just an array that has an account and a key store. So this just has a single account in it. And a key store can have many accounts, but in this we're referencing we have a lot of accounts that may have the same key stores. Has URL, returning to URL. So it's now a wallet. Cool. So they call new key store so there's an array of backends which are just a key store, and they got one with not much in it. Then they call accounts new manager with the backends. So what's new manager then? And accounts manager. So somewhere here is the manager, has a list of backends which are just key stores, same name. Cache all the wallets from all registered backends. Quit lock new manager, takes a list of backends, retrieves initial wallets from the backends. So it goes through the backends, merge wallets and backends. Exciting. So it's funny because wallets, backends, and key stores are probably all very similar, and they all just manage accounts. Maybe. It's probably minor differences that I don't fully understand right now. You got account manager being assembled, which has your lists, and they chuck the wallets in there. And the wallets comes from the backends. So it's literally just digging through. When it does this new key store, it ends up digging through your key store directory, which defaults to key store. And then puts that into the account manager structure here, which takes the backend, takes the wallets out of the backend, and puts that in AM update. This wallet event loop, listening for notifications from the backend. Loop until termination, takes the lock. Update RS. No, this gets deferred to after it closes. Wallet arrived, wallet dropped. Cool. So that looks like it kind of makes sense what's doing there. So if I go back up to the commands directory, there is Geth Account Commands /list calls account lists. Makes config, which is going to have it in there. Gets a list of wallets. Each wallet has an account and goes for each of them. So it's just account, %d index, account address, account URL. Ethereum. Let's see if I can quickly find an example of this without, because my virtual machine won't handle it. Give me some pictures. No. Nanopool, getting started. No. Keys. Add explorable transactions. Management APIs, faucets. Spin. Programmatically. No, because they go through the Web3 ABI contracts, managing your accounts. Creates new, passphrase, returns the address. Accounts list. And that's just the key store directory address. That address is what the public address is. Call new. What does new do then? Accounts new. Where are you? Up the top, wallet, not for us, pre-sale wallets, I guess. Account list, new. Account creates a new account. Sets no config, gets that standard crap. They're all standard. That's like a generic 4000, that's a generic 1, that's a key store directory. Password, get passphrase, so clear. CD home, Geth account, new. Your account is locked. Hello. Go over here. Enter. Hello. No passphrase, no passphrase. Out of memory, because I can't do it on this machine. Cool. Keystore.storekey, key directory password. Alright, so store key. Up into accounts. Go, source, GitHub, Ethereum, Go, accounts, ACK, store key. Key store key. Key store passphrase, I guess. Key store plain. I think it must be in this key store passphrase because it's just straight off the library. So this is called off key store plain. Don't know what keys. up. Key store. Key. I think it's in key store. Ah, no, that's an interface. So if we go into key store, accounts, key store, that is under the write package / store key. No, completely wrong. It's key store passphrase. So this is under the key store package, and then we got this key store dot store key function. Generates a new key, encrypts it with auth, which is just the password we've entered. So get passphrase. Utils.make password list. Context. So I think that really just, this wraps the whole typing a password into the terminal, or if you pass to it a file which goes along the lines of Geth.account new password and pass it file, so file.txt, it'll actually read the file instead of just prompting you. But it won't actually prompt this up because this calls it. I won't look into that now because it's really just getting a password as a string, and you call store key, which is this store key, and you pass it a string in a directory, and it calls store new key, creates a new passphrase with the directory, and that blah, store new key, and passes the auth, rand.reader. What's rand? It's just a library, isn't it? Crypto rand. Read. Reader.read on read full. Random. Make bytes. Rand read. It's equals 10. So they make an array of bytes. They read. Takes an array of bytes. Calls reader.read using io.read full. The slash, so you put in randomness in there. Store key random.reader. No, reader. Rand read. It's global shared instance random number generator. So you can read from this and it gives you random, I guess. they're giving something to give random bytes, and they call this store new key, which is not stored here, which is stored in key. So the key takes a key store, random reader, an authentication string, and returns a key and an account. And they call new key, yay, with rand. If error equals nil, A equals accounts, address, key.address, and accounts URL. Scheme, key store scheme, and path KS. Path is a key store, so they pass it to directory. Accounts.url. Alright, this has got too much going on. Go away. Exit. So accounts.account, address URL, and they make the URL. And the URL takes a scheme and a path. Don't know what key store scheme is. Key store. But lots of them use it. Cache. They're all using this key store scheme. But where are they getting it from? Const. Key store. So in here is a protocol scheme prefixing account and wallet URLs. Did I lose that stuff I was playing with before? So they put that, which is just key store, in front of everything. Protocol scheme, prefixing account and wallet URLs. And then it's got the actual URL of the key. And then a dash, I guess. Who knows? Quit, exit. And then go back here. They make an accounts URL by taking the key store scheme, which is just key store as a string, and the path where they're joining the key file name and the key.address. So this new key makes a key that has the address and the actual private key in it. Store new key. Marshall, Cipher, Crypto. I've lost store key. Oh, so they make a new key store passphrase. So they make a new key store, then call it straight away with this store key. And then store key, store new key, creates a new key from random. Where's auth come into this then? Just there. They make a new key. Then they call KS store key, the key and the authentication. And take the URL path. So what's new key do then? Generates key, elliptic curve key, SHA-256 and random. So it literally just makes new key from ECSDA, returns a key. So that literally just extracts the private key and the public key from this other format, this ectasa, elliptic curve, something. Puts it into this structure, makes an ID, UUID new random. What's UUID? P-Bore Man. Spin. Generates and expects UUIDs based on that. It is a convenience for new random string. So this is really just a standardized way of making a UUID, which is what goes into store key. No, another one, key. Where'd it go? There's too many circles going on here. So, store new key. Oh, that's what it did. There it is. Key.address. And all it really does is it takes this new key, which makes it an elliptical one, it calls keystore.storeKey. Which is in the interface, which is in here, so it should have a store key that actually gets called. Here. That's the library top function, which ends up calling this one below it anyway. So they encrypt the key. So you generate the key and then you encrypt it later with your password. That makes sense, I guess. Encrypt key, case key authentication. I don't really want to dig into the encryption of it because the more you dig into that, the less you actually get to focus on the other stuff. Write temporary key file. If skip verification, which should always be turned off. Rename temp key, temp name into file name. So they write it into the temporary. And then they return the name, which is a file name. No, returns an error. OS rename temp name to file name. So then you save it into the file, and that is the end, because it gets saved into that when it makes this temporary file, writes the key JSON, encrypt key turns out in key. Alright, screw it. Encrypt key. If pass equals nil. Encrypted data B3. Takes the data, encrypt key, makes a salt script, blah, from the auth. Salt equals make that random into the salt, so then make the random salt. And salt is just literally, you add that to the end of the password, and you save it next to the file, but it just means when people are trying to guess passwords, they can't pre-guess them all because they got all this random stuff added to the end. Like, yes, it's written right there and you can find it, but you can't pre-guess it. Derived key equals scripts.key. Script a thing up here. Golang crypto script. Yeah, it is. Crypto KCAC 256. Ciphertext. Yeah, proper crypto stuff. NRP DK length salt. Ethereum accounts JSON example. Cool. No, alright, so I think that's probably where I'll wrap it up today. The account file, is there anything else in this config? No, account command. Is really just, there's an account manager, it's got a key store or accounts or wallets or whatever you want to call them. They're just different types of the same thing and they sort of reference each other a lot. That might not be accurate, but I think it paints a good enough model for me to work with right now. And they keep in a list of accounts, and the accounts is an address with a public key that you can use, and it's also got where the file is stored, and the key which has the public key. So those get stored, and the end result is you should just be able to call the node has an account manager. That account manager has a list of wallets. The wallets has a list of accounts, and then you can go through them. And that was the end result. They just want this really simple function to go through them when you need to find them. In this wallet, there's some that are unlocked, which means you don't have to dig out the passcode. And that's all for that one. Thanks, guys.